Hello, everybody. This is a lesson for my Pre-Cal 11 students. It's really just an introduction to absolute value. Well, the unit's called absolute value and reciprocal function, but today we're just going to introduce absolute value and then just do a little bit of graphing review from grade 10 and from chapter 3 earlier this year. So this will be a very quick little introduction here. So can everybody open up their new booklet that we just handed out today? And we'll skip this page. You'll figure out these definitions as we go. There's a new book for you right there. All right, absolute value represents the magnitude of a number, how big it is, or, and this is the important part, its distance from zero on a number line, regardless of its sign or direction. For a real number, the absolute value is written as the absolute value of A, where absolute value is just these straight up and down brackets, and it's always a positive number. So two vertical bars around a number are used to represent the absolute value of that number or that expression. So the absolute value of 5 is 5. The absolute value of negative 5 is 5. The absolute value of 0 is 0. And on a number line, if we're looking at on a number line what the absolute value of negative 7 is, well, notice on a number line, negative 7 is here, positive 7 is here, but they both have the same distance to 0. They both have a distance of 7, even though they're directionally apart from each other. So that's why that distance is the absolute value of either negative 7 or 7. So as a piece of algebra, we'd say the absolute value of A is positive A if A is greater than or equal to 0, and it's negative of A if A is less than 0. So let's evaluate a few. Absolute value of 3 is 3. The absolute value of negative 7 is positive 7. The absolute value of 9 is 9. The absolute value of negative 12 is positive 12. And the absolute value of 0 is itself just 0. Okay, you try one. Let's call these A, B, C, D, E, F, G, and H. Put all those numbers onto the number line below. That way we can put them in order from least to greatest. You used to do stuff like this in grade 9, only without the absolute value symbols. Remember that? Where you had fractions and decimals and you had to be able to order them as real numbers on a real number line. So we'll give you a minute to try this. I'll just pause the video while people give this a try. Okay, hopefully you gave that a try. And here's what you got. In order, the furthest left is the one of only two of them that actually remain negative. So D is the furthest left, so that's the smallest. Then G, then F, then E, which is just a little bit smaller at 2.4 than H is at 2.5. And then C, and then B, and then A. So there they are, ordered from least to greatest. Okay, any questions about that? All right, let's do some calculations now. Recall that an expression is a mathematical statement or a math sentence. Visually, there's no equal sign, or if you do put an equal sign, you don't need to because you don't have another side. It's not an equation, it's just an expression. So absolute value symbols should be treated the same way that you treat brackets. Evaluate the absolute value of a numerical expression by first applying the order of operations inside the absolute value symbol and then taking the absolute value of the result. So deal with these absolute value brackets first. Well, the absolute value of 4 is 4. The absolute value of negative 6 is 6, and this is still a subtract. What's different about what you do with normal brackets is with normal brackets you'd probably think, oh, I'll just cancel those negatives. But in this case you can't because you have to apply the absolute value before you consider the subtraction. So this is negative 2. All right, with that kind of as an example, I'll pause the video again, give the rest of them on this page a try. There's B, C, D, E, F. So I'll give you a few minutes here. Again, I'll pause the video. People watching this should pause and give B, C, D, and F a try here. Let's see if I can get them all on one page. There we go. So pause the video right there and give those a try. All right, how'd those go? Let's run through them real quick here. All right, so on B, 2 minus 7 is negative 5, so I'll write that as minus 3 times the absolute value of negative 5. But the absolute value of negative 5 is 5. So what I would do is I would just switch that. I've dealt with the absolute value bracket. I just switch it to a regular bracket. That's the way I would deal with it. You can use the times symbol if you want. You can use a dot. You can use an X. You almost never see me using an X for multiply. That symbol's kind of dead to me. But as long as you understand that now the multiply has to happen before the subtraction. So that's 5 minus 15. And the final answer is negative 10. How did that go? I'm seeing a few nods positive, but I'm seeing a few people erasing. So, okay, so that caught a few of you. All right, let's try C now. The absolute values are the absolute outside. So basically everything on the inside has to happen first. So it's negative 2, and 5 minus 7 is 2. Sorry, negative 2. But here's another reason negatives go away. What's a negative 2 times itself? Positive 4. And then plus 6. So this is negative 2 times 4 is negative 8 plus 6. So that's negative 2, but it's inside the absolute value bracket. So the final answer is 2. How did that one go? All right, this one here, there's nothing to do in the bracket, so I just apply the rule of the bracket, which means the negatives go away. So that one's just 1. Okay, and then this one, same deal. Do what's inside the bracket, which makes that a negative 4. Then apply the rule of the bracket, which makes it a 4. And then on the last one, I'd have negative 36 plus 25, which would be negative 11, but that's inside an absolute value bracket, so that's going to be just 11. How did those go? My advice would be that if you got like more than one little mistake, you made a couple of mistakes or more than a couple of mistakes, definitely try some of these questions. I'll make it an optional assignment. If you blew through those as fast as I just did and as error-free as I just did, then you probably don't need to waste your time with that. But if you're one of those people that you could use a little just bed mass practice, even if it wasn't the absolute values that caught you, you made some bed mass errors. It's amazing how many people make this error. Anybody make that a 2? Whoops, that's a bed mass error. Don't do that. So if you're one of the people who might have made those little mistakes like that, then by all means, spend a few minutes and try some practice on those. Okay? Same thing with if you had a hard time putting the questions in order here, the numbers in order. I think there's a couple of questions in this assignment where they get you to do that. So I'll leave it to you how much practice you want to do on that. And that's basically our introductory lesson to absolute value. Before we go on to the rest of this unit, they want to make sure you have your graphing skills for both linear and quadratic. Now, quadratic we did this year, right? It was chapter 3, but we haven't done much graphing of just straight lines from grade 10. So here's a quick little grade 10 review, right? Remember that when you write an equation in the form y equals mx plus b, b is the y-intercept and m is the slope. Oh, why am I writing it? It's right there. B is the y-intercept and m is the slope. And so if you are given the equation in this form, that negative 6 is where your y-intercept is. And you always think of this m number, this slope, as a fraction. So 3 to me is the fraction 3 over 1. 3 is your rise, which means in this case, since it's positive, up. And 1 is your run, and the positive nature of the number 1 means that you run to the right. So from this dot that I just made at negative 6, I go up 3 and over 1, up 3 and over 1, up 3 and over 1, and then I connect the dots, and there's my line. Remember that a negative slope means down, but keep in mind that negative could be on either part of the fraction. It doesn't matter whether you think of it at the top or the bottom. So negative 2 is my y-intercept, so there's negative 2 is the y-intercept. But I can think of this as negative 1 over 3, which would mean down 1 and right 3. So if I do that, I go down 1 and right 3, and I get this dot. Or notice I could think of it as 1 over negative 3, which would mean up 1 and left 3. So starting from my y-intercept, up 1 and left 3, and notice I hit the same line either way. Of course, slopes can be fractions that aren't simplified either, right? Notice that negative 1 over 3 is the same thing as negative 2 over 6. So I could have started here and gone uh, 2 down and 6 to the right. And I'd still hit the line. So you can make as many dots as you want. You only ever really need 2 dots to draw a straight line. But if I was doing them, I would make sure that I did maybe more than 2, just to make sure I have a nice straight line that I can take my ruler and draw it through. So that's a quick refresher on how to graph straight lines. And notice 3 and 4 are exactly the same type. And then notice that number 6, no, not number 6. So number 8 and number 7 don't have an x and a y. You have to remember which one's vertical and which one's horizontal. So we'll see if you can do that. So we'll leave the rest of these for you to try. You have until Tuesday to do them. We'll correct them together on Tuesday. And now let's do a quick refresher on how to graph parabolas from chapter 3. Right? Chapters 3 and 4 were quadratics. But remember, chapter 4 was mostly algebra, right? We did the quadratic formula and some word problems and discriminants. Chapter 3 was where kind of the nuts and bolts of how to graph these is. So for this one, I would graph this on just by going, hey, I know what y equals x squared looks like. This minus 9 just moves the vertex down 9 places. And how do you get this nice curve? Well, if you look for other points, you know that because there's a 1 here, you can say that it's the shape of y equals x squared, and y equals x squared always behaves like this. If you start at 0, 0, and then move from x is 0 to x is 1, you go 1 up. If you move 2 over from 0, you go 4 up. If you move 3 over, you go 9 up. And that's the way I do this. So I go 1 over, 1 up, 2 over, 4 up, 3 over, 9 up, which, by the way, ends up hitting my x-intercept. And then I also know that the axis of symmetry cuts this thing in half, so they're symmetrical points on that side, and then I'd use that to draw my nice curved parabola. Don't make a pointy Pope's hat. Actually, that's already a bit too pointy, but you get the idea. There we go. So there's my parabola. Now this one, what did they do with this one? Chances are with this one, well, there is one point that you know right away just looking at the equation. Do you remember what it is? What's the one point that this tells me without changing it much at all? Remember, it tells me the y-intercept, right? The constant when you're in standard form is the y-intercept, because think about it, if x is 0, all you get is 6. But that's about all that you know when you're in standard form. So I might want to go back to completing the square. Remember, need a quick refresher on complete the square. Factor a negative 1 out of the first 2 terms. Leave that constant over here with some room. And then what number goes here? Do you remember this? You take the b value, which is in this case 1, you take half of it and square it to complete your perfect square trinomial. So half of 1 is a half, squared is a quarter. Now you can't just add a quarter without messing up what the equation is. So minus it right away. But if I minus it inside the bracket, after I times it by negative 1, it'll be plus 1/4 outside the bracket. So y is equal to negative 1, and I don't really need the 1. Now factor that, x plus 1/2 squared, and then 1/4 plus 24/4. I could just, you know what, I have to graph this. I'll leave it as a mixed number, 6 1/4. And that's what this vertex is, right? It's 1/2 to the left. Remember, the vertex is the opposite rule here. 1/2 to the left and 6 1/4 up. So 1/2 to the left, 6 1/4, there it is. And then I would use, there's a bunch of things I can do. I can use the symmetry for the y-intercept, and I know there's a point there. And then I just use my same counting rule. I know that because this is a 1, I go 1 over, 1 down, 2 over, 1, 2, 3, 4 down, etc., until I've graphed my parabola. Okay? So, remember how to graph parabolas. When they're in this nice, easy form where I can see the vertex, I don't have to do much. But if they're not in vertex form, I have to rearrange them. Use my complete the square skills. You know, they didn't do that for the linear. Let me just go back to linear for a sec. None of these examples aren't in y equals mx plus b. Let's just make one up. What if I gave you one like this? What would be your strategy for graphing him? Here, let's do this. There. Let's just do this one here sort of together. What would you do with that? I have kind of two strategies in my head. Strategy number one is, actually I have three. Strategy number one is you can go back to grade 7 and just make a big table of values, right? Make numbers for x that y would equal and then connect the dots when you draw them. That's a little too babyish. Come on, we're long past grade 7. How about we find just a table of values with just two values? I could graph this just using the intercepts, right? The x-intercept happens when y is 0. So 2x minus 3 times 0 equals 6. So 2x is equal to 6, so x is equal to 3. So there we go, 1, 2, 3. And the y-intercept happens when x is 0. Oops. So y is negative 2, and there we go. Done. We got it. So there's one strategy. Now, why did I like that strategy for this question? Well, I noticed right away 2 and 3 are both factors of 6. So I knew I'd get nice, easy to graph whole numbers if I looked for my intercepts. What if this had been 2x minus 3y is equal to 7? I really don't want to graph 7 halves or 7 thirds. So I'd use a different strategy. Let's put a grid back again. Oops. Paste. There we go. Move up a bit. There we go. What would I do for this one? I think for this one, I would change this to y equals mx plus b using my algebra skills. So negative 3y is equal to negative 2x plus 7. And then divide both sides of the equation by negative 3. Notice the negatives cancel on the x term. And then I'd have to kind of estimate a little bit. 7 thirds negative, that's negative 2 and a third. So negative 2 and then maybe a third of the way, there we go. And then this is my rise over run. So I'm going up 2 every time I go right 3. So go up 2 and right 1, 2, 3. So I'm about there now. And maybe I'll get another one. Up 2 and right 1, 2, 3. And there we go. So that's how I do those. If the numbers are nice and easy and they work out nice, I might use my intercepts to graph it like that. But otherwise, most of the time, if you're given a linear equation that's in anything but y equals mx plus b form, I'll probably change it to y equals mx plus b form. Because it's not very hard algebraically to do that. So if any of the practice ones you run across don't look like y equals mx plus b already, you can always just change it to that. So there we go. So there's a quick refresher on all the graphing skills we'll need for Chapter 7, because we do a fair amount of graphing in Chapter 7. Okay, so you had u tries up to number 8 in the linear, and in the quadratics, you have 3, 4, 5, 6, 7, 8 again. So basically, you have till Tuesday to get those kind of in line. We'll go over them together. I actually already have a key for them up on the blog. And that's as far as we'll go in Chapter 7. So we'll end the video there. That's the lesson for today. Thanks for watching.